Okay, this is the second video on looking at the addition of two functions to form a new function. In this video, we have a linear function f and a function g involving a square root function. So this example should be more interesting than the previous video because g certainly has a limited domain. Right? Any x value that makes the expression under the square root negative will not be in the domain of g. So let's start by just investigating what our function f plus g would do with an x value of 0. Right? By definition, we should take our function f evaluated at 0, take our function g evaluated at 0 and add those two numbers together. Well, f of 0 is going to be 1. G of 0, when we plug 0 in for x, we're going to get the square root of negative 1. And that is not a real number. Right? So 0 is not in the domain of f plus g of x. Okay? So whenever we add two functions together, right, as we saw in the last video, the domain of that f plus g, that domain of the new function formed from adding the two functions together, is going to be only the x values that are common to the domains of f and g. Okay. So in this video, let's compute the general formula for f plus g, and then determine the domain of this new function. So by definition, this is f of x plus g of x. So we're going to just take our two formulas and add them together. The formula for f of x is x plus 1. The formula for g of x is the square root of x minus 1. So combining like terms, which we can't really do much with since these terms are not like, is in this case going to leave us with f plus g of x equal to x plus 1 plus the square root of x minus 1. Okay, so here is the formula for our function f plus g. We next want to find the domain for this function. Recall that the domain of f plus g is just going to be the intersection of the domains of f and g, right? The x's that are common to both domains. So let's start by just figuring out the domain of f and g separately. F is a polynomial, so its domain is going to be all the real numbers. Right, so let's just go ahead and graph its domain on a number line. And then think about the domain of g. Okay, well, g involves a square root. Its domain is going to be any x that satisfies the inequality x minus 1 is greater than or equal to 0. Right? As long as this expression is non-negative, then the square root of that expression will be a real number. To solve this inequality, we're just going to add 1 to both sides. So the domain of g starts at 1 and includes all the x values larger than 1. So now that we've determined each domain separately, we can go ahead and determine the domain of f plus g. It is the intersection of these two domains. It's the x's common to both of these lines. Well, we see that these lines both have 1 in common, and they also have x values larger than 1 in common. So this is the graph of the domain of f plus g in interval notation. that is 1 to infinity, bracket around the 1, since it's included in the domain.